All right, so we continue to look. Again, just a quick reminder, we had, we're saying that we're doing calculus, okay? And then we said that calculus has got two areas. There's differential, and then there's integral, okay? Now, we have focused on the differential for now, and we're saying that the differential starts off by understanding the limits. Once we understand the limits, we try to understand what changes or derivatives, because the limit tries to look at a point, okay? Normally, the point, or frequently, the point that is not easily accessible, okay? So that's what calculus focuses on. So now we are saying that we are also trying to get derivatives now. These are going to help us to understand change or motion and things like that. So once we understand, once we know how to get derivatives, that's when we can go to integral calculus. So we are now at this point where we're looking at derivatives. Okay, so derivatives, we said that we can obtain O using the limit definition. Once we use the limit definition, we can get various kinds of derivatives, but this is not easy, okay? It's almost like in manual means. So we said the other way that we can do it is to use the rules, okay? And now the rules, we have looked at the power rule, which we said is found in almost all the rules, okay? It's a prerequisite for all other rules. If you don't know the power rule, it's very difficult for us to even talk about any other rule, okay? So this is primary, and this is primary. Once we know these two, we can extend now to the other rules. The other rules that we looked at the chain rule, and then we looked at the product rule, okay, product rule. And now we continue and look at the quotient rule today, okay? So this one is where you can't use, so all these are other rules, it's where you can't directly use the product, the power rule, okay? So now the power rule, we said was important, and it helps us with these other ones, but where it can't be used, then you have to extend to these ones. The product rule, the quotient rule, will look at something like, let's say you have x squared over x plus 1. Now you want to obtain the derivative of this one. You can't just come and say, I'll use power rule here and power rule there. It doesn't work like that. You need another rule, okay? But if you used limit definition, you'd actually just use it the way it is here, okay? But then it's a lot of work to do to get a derivative like this one if you use the limit definition, okay? So we're going to focus on the quotient rule in this one. Now the quotient rule, like we said, it's where you have, let's say, a function of form fx, okay? Remember, this is a representation of a function over gx, okay? So when you have this one, the derivative of this one, we can say it's d, okay? Now, to show that we're actually working with these functions, we can say this and that, okay, over dx. They say, now this is very crucial, you would think that the primary function is this one. So it's the one that must appear first, okay? But then in this case, it's not. So the one that appears first is gx, okay? So we go gx, and that's the only thing to remember, okay? That the one that overrules the whole function, it's the gx, not the fx. And so here we're going to get the derivative of fx, okay? We get the derivative of fx, and we take away now the main function that we would have thought would be the main function. So now it comes here, which is fx, then the derivative of gx comes this side, okay? So the main thing to remember is that the function to start with is this one, and then everything else can follow after that, because you can't repeat this here on the numerator. So once you know that you've used it, then here you have the derivative of the other function, then here you have the other function and the derivative of this function here, okay? And then we said that the one that rules this function, to think about it this way, is the gx. So here we're going to have gx, and then we're going to square it, Okay, so that is this, right? Now, what we need to remember also is that this function, okay, this function can also be represented in terms of u and v, something that's easier to see, okay? So now we're obtaining a derivative of this function because we're saying that u is equal to fx, okay? And we're saying that v is equal to gx. So we're putting these two together. Now we say that we're going to get the derivative of, we're going to start with v as our start function. Then we're going to obtain d u over dx. Okay. Then we can't interchange these. They have to come the same format. Then u is the one that comes this side, and then we do dv over dx over v squared. Okay, so this is another form of that same function, right? So we have these two functions. There's a derivative here. Okay, you can see it in this format. And then there's a derivative in this one here. You can also see it in that format. What is very important, like we said, is to understand that you're starting with a divisor. Okay, starting with the divisor. Then everything else changes from there. And then the divisor is one that's coming down here as well. Okay, let me repeat this. Very important. We have gx and then we have fx. The normal thought would have been we start with fx here, okay, and then the derivative of gx. But that's not the way it is. We start with gx, the divisor, then the derivative of the numerator. Then that's when the numerator comes, and then the derivative of the denominator. And then here we square the function. We don't do any derivative. We square the divisor, the denominator, the function at the bottom. We square it here. You can see here, it's the same picture. We have v, we have u, and then we have their derivatives here. And then at the bottom, we square the function.